Some have speculated that Lewis and Clark traversed it to reach Cathlopodal village. There was talk at one time of it being a site for decommissioned ships or possibly being drained for agricultural purposes. And folklore has it that a World War II plane crashed and is still buried in the middle. Located just minutes west of downtown Vancouver and the Interstate 5 freeway, this water body is Vancouver Lake. Covering approximately 2,300 acres with more than 7 miles of shoreline, Vancouver Lake is the largest lake in the area. It is a shallow lake that rises and falls with the seasons and tidal fluctuations. The average depth is about 4 feet. Regarded as a community resource, the lake and surrounding area provide a host of uses and recreational opportunities. Draws to the lake include swimming, paddling, windsurfing, wildlife viewing, as well as home to the Vancouver Lake Crew, the Vancouver Lake Sailing Club, and the popular Vancouver Lake Regional Park.
We'll start the year with a half marathon. We will permit anywhere from 2 to 3 marathons, triathlons. They love the site because of the series of trails and obviously access to the water. We have a series of regattas that are scheduled in the spring. Those are typically high school regattas from all over the Pacific Northwest. Schools come down and compete. We also have a series of weddings, company picnics, corporate picnics, family reunions at our reservable shelters. And beyond that, folks just come down and walk here daily, wildlife viewing, as well as use this as a trailhead.
It's actually the best small boat sailing in the area because it is a large body of water and we have steady wind and there's no boat traffic. And it's perfect for young sailors in small boats. If somebody hasn't been sailing, I would encourage them to go out for a sail because it is so peaceful, so relaxing. Just you, the boat, and the wind, and in the moment all the time.
Usually around the month of August, when the lake level drops and the temperature heats up, there can be one limitation to enjoying water activities on Vancouver Lake. It is a very small organism, too small to be seen with the naked eye. Mostly known for its beneficial qualities, such as being an integral part of the food web and providing us with oxygen. But when phytoplankton is left unchecked, their colonies can be seen across vast stretches of the lake. Most of these algae blooms can be nothing more than a visual nuisance. However, in the case of cyanobacteria, a specific variety of phytoplankton, it has the potential to be harmful to humans and pets. Annual summer algae blooms have been occurring in Vancouver Lake for decades, but when a cyanobacteria bloom reaches a critical level, Vancouver Lake must be closed to human contact.
Some species of cyanobacteria produce toxins that can cause damage to the liver and to the kidneys, and in some rare cases can cause respiratory issues that could be fatal. The World Health Organization is what sets the guidelines for cyanobacteria levels and thresholds. There's 2 specific species in the North Pacific that we're worried about.
Figuring out what causes algae blooms at Vancouver Lake is as complicated as the water system itself. Before the construction of dikes and hydroelectric dams, Vancouver Lake operated much like a large side stream to the Columbia River. The lake was connected to the Columbia by a slough to the south and another slough to the north known as Lake River. While dikes and dams help to protect property and infrastructure from flooding, a dike built in the 1900s cut off the lake's south connection to the Columbia River. With this water source gone, sediment and materials began to accumulate in the lake rather than being scoured out by seasonal high water flows. Over time, the lake became murky or turbid, and the bottom soft and muddy.
There have been accounts that that there used to be a sandy bottom, a gravelly bottom, that the water used to be clearer, the water used to flow through more and actually flush the system out. What it means when you have a shallow lake is that the movement of water, the movement of material, the storage of material in the lake is going to be much different. It's got an extensive amount of bottom sediment that's exposed to the water.
In the 1980s, restoration efforts were attempted at Vancouver Lake to bring back Columbia River flows to improve hydrology, water clarity, and quality. An artificial flushing channel was constructed to reconnect the south end of the lake to the Columbia River. Also, dredging was performed on part of the lake bottom to remove sediment and increase water movement. Much of the dredged material was placed into the middle of the lake, which created a 50-acre island.
The flushing channel only flows one way. It's got a tide gate on the end, so when the Columbia River comes up and the water level's higher on the Columbia River side than the lake side, it pushes that gate, that flap gate open. And then when the Columbia River drops, the flap gate closes. So it's more just either coming in through the flushing channel or not. Lake River, on the other hand, both pushes in and flows out. So when the Columbia River is up, the water will be coming in from Lake River as well as the flushing channel for different periods of time. The flushing channel will shut down and Lake River may continue to flow into the lake.
Unfortunately, the flushing channel and dredging of Vancouver Lake did not quite accomplish what was hoped for, and algae blooms would still appear in the summer. To understand what might be causing these blooms involves taking a comprehensive approach to how the lake operates in its present state. This includes water sources, hydrology, food web interactions, and what is in the water, such as sediment, nutrients, and contaminants. The movement and sources of water varies at Vancouver Lake. A year-round tributary is Burnt Bridge Creek. Its watershed encompasses 28 square miles of mostly developed and urbanized land. In addition, during certain times of the year, the 11-mile stretch of Lake River and its 4 main tributaries, which are Salmon, Gee, Whipple, and Flume Creek, can also flow into Vancouver Lake. When this happens, basically 1/3 of the county is Vancouver Lake's watershed. Plus, the Columbia River can enter from the north through Lake River or the south through the flushing channel, making Vancouver Lake's watershed even larger. These contributing elements make the lake a large depository for what's being carried along by all these water sources.
Whatever comes off people's yards and roofs and buildings and commercial areas, it can be sediment, it can be dirt from construction sites, it can be phosphorus and nitrogen, or what we call nutrients from fertilizers and other sources. It can be bacteria that comes from both wildlife sources as well as potentially human sources that is carried in stormwater systems or that is discharged to streams. Potentially pesticides, herbicides, some metals. There can be a lot of stuff in the water, and all of it could potentially end up in Vancouver Lake.
Contributing factors that lead to algae blooms are sunlight, excess nutrients, poor water circulation, and warm water temperatures. Because Vancouver Lake is shallow, there is more exposure of the water to the bottom. Lacking strong flows and circulation, sediment and nutrients lie on the bottom of the lake and can be easily stirred back up into the water. To ensure visitor safety, Clark County Public Health collects water samples on a regular basis during the summer months in the Vancouver Lake Park swim area to check for cyanobacteria.
As far as sampling, yes, we go to weekly, and then sometimes we'll go out twice a week to monitor the scum layer. It depends. In 2009, the cyanobacteria bloom lasted more than a month and a half. And that was due to our long, warm, sunny days, and there was really no movement of water. What we do is issue a health advisory to avoid contact with water, with pets and humans, avoid contact with water at the lake.
Concerned about the reoccurring cyanobacteria blooms, as well as the health of Vancouver Lake, in 2004, local agencies and nearby neighbors banded together to form the Vancouver Lake Watershed Partnership. This initial endeavor consisted of the Port of Vancouver, Clark County, the City of Vancouver, and the Fruit Valley Neighborhood Association. Soon after, the group invited other partners with an interest and stakeholder in Vancouver Lake, which includes federal, state, and public agencies, as well as other organizations and citizens.
Vancouver Lake is, just a treasure to the community, and this park is a beautiful park and people love it, and it's within the viewshed of the city, and people are constantly bird watching and looking at wildlife, using the lake for really almost national sailing, national rowing, and then just passive bird watching and wildlife viewing. It's a community treasure that's very much worth saving, and so that's really what we're about, is trying to figure out how to do that and how to protect it.
While past studies of the lake were helpful, the partnership created a research plan to fill in the data gaps by sound, technical, and scientific means. Funding for their activities is made possible by an intergovernmental agreement between the Port of Vancouver, City of Vancouver, and Clark County. The group has been leveraging their resources by applying for grants to make dollars go further. One such grant is for the Aquatic Ecology Laboratory at Washington State University, Vancouver, to quantify the factors that influence cyanobacterial blooms.
In every water body, fresh or salt water, there are a lot of organisms that float freely in the water, and they're referred to as plankton. And we generally group them into two major types of plankton. The phytoplankton, those are organisms that can photosynthesize and use sunlight to produce their own food. These would be the plants, if you will, of aquatic systems. And then there are the zooplankton, or the animal-type plankton. And in general, the phytoplankton use sunlight to produce their food, and they grow that way. The zooplankton eat the phytoplankton. Those zooplankton are then consumed by fish. So the food web starts with the phytoplankton. They get eaten by zooplankton, which get eaten by fish.
Algae blooms appear virtually around the globe. What causes the bloom is often specific to just that water system. Understanding why cyanobacterial blooms reoccur at Vancouver Lake might be found at the food web level. This involves observing what phytoplankton are eating and what is or is not eating them.
And what we're really interested in understanding is, how does the bloom start, how does the bloom degrade, and who or what is responsible for that. When we think of cyanobacteria as a phytoplankton, we know they need light, we know they need nutrients such as nitrogen and phosphorus, and we know that zooplankton eat them. And so what we're trying to understand is the role that the zooplankton play in eating these cyanobacteria, or in eating the other algae that are present with them, and how the consumption of algae or cyanobacteria by the zooplankton helps to contribute to the buildup or the degradation of the bloom.
Another study that will soon be underway is a joint funding agreement with a federal agency. The USGS, or United States Geological Survey, will be placing 3 water monitoring stations at Lake River, Burnt Bridge Creek, and the Flushing Channel. They will also be doing research to analyze groundwater discharge and lake bottom sediment. This will be the most comprehensive study to try and understand the lake's hydrology, along with what's in the water and where it's coming from.
We're trying to fill those larger data gaps in where the water is coming from and what's in the water, and that's the hydrology and nutrient budget that we're trying to do. That will tell us where all the water comes from and what's in the water, and that'll really be the most significant data gap for figuring out how the lake works and helping to set up some alternative management strategies.
Through the combined research currently being undertaken in past studies, within the next 3 to 5 years, the Vancouver Lake Watershed Partnership hopes to receive the necessary information to fill in the data gaps. They will then work on potential strategies to improve Vancouver Lake. From there, the next steps will be to share their findings with the community and then work toward consensus for an economically viable solution for Vancouver Lake.
So there's just a lot of interest about Vancouver Lake. In terms of our approach, we're trying to understand how the lake functions to make sure that when we come up with a solution or an alternative, that it's the right one and actually helps us fix, to the degree we can, the problems that are affecting our beneficial use of the lake.
I've been a member of the Vancouver Lake Watershed Partnership since its beginning. Volunteered for that as a member of the sailing community because we know the lake is important to us. And it's going to be a long-term fix. I've advised our members here when they ask me that it's going to be a long time. There's no quick fix. We have to study what the issue is, come up with solutions, and then fix it.
For more information about Vancouver Lake, visit the Vancouver Lake Watershed Partnership's website at vancouverlakepartnership.org.